All right, good night to everyone. Good night. Can you guys see my screen?
Yes, sir.
All right, great. So we're gonna make a start now. Um, Basically, last week's class we would have wrapped up everything when it deals with creating a program for your SBA. So what we're gonna do, we're just going to review how to create a program, basically, and we're gonna review that. So if you guys have any questions on that, now will be the time to clarify it so that you can properly create the program for your SBA. And then we're going to move on to the other part of your SBA, which is the trace table, basically. All right, so when it comes to creating a program, I would have given you guys a document. So I created a document for you guys showing you the basic structure of creating a Pascal program. All Pascal programs must start with the keyword program, and then you put a title after that keyword. So for example, this one here, I have that keyword program, and then I have um, the, the title here basically after that keyword. So that's the first part there. Then the second part we looked at is that when you want to declare your variables, you always start with that var keyword. And this is the structure or the syntax as to how to create a variable, declare a variable. Is that variable name, colon, data type. So as you can see here, this is an example once again. Var followed by variable name, colon, data type. So that's how you declare. Then after that, we have begin. So that's the beginning of our statements, our input statements, our processing statements, our output statements. They are going to start after that begin keyword. So right after that begin keyword is where we do our initializing. So after that begin keyword, we do our initializing. This is an example as to how you initialize. You give the name of the variable. Remember, you must declare that variable first. You give the name of the variable, followed by a colon, followed by equal sign, and whatever value you want that variable to store. That is how you initialize a variable. So right after the begin keyword, you put all your initializations for your variable, followed by a semicolon. So that's the first three parts of all programs when you're creating a Pascal program. Then after that, it's up to you to add whatever you want. You add your input, your processing, and your output. So we looked at when you want to output something, you use the write keyword. In this case, we're using write line. So the syntax is basically write line, that's the keyword, followed by open brackets. Whenever you want to output a phrase, it must be in single quotation mark, and then you close that bracket. If you want to output a variable, you must add a comma to separate that phrase from the variable, and you type in the name of the variable. The variable could come first, the phrase could come second, whichever order you want to put it in. But the key thing to remember is that all phrases go in the quotation mark, whereas the variable does not go in the quotation mark. This here is an example as to input. So what this line is going to do, so this is called read line. This is going to read whatever the person is typing on the screen. And in the brackets is the name of the variable it is going to store that value into. So that's going to be the variable called max. So this is a example of output and input. We also learned how to add comments. So remember, a comment is basically inside of a curly bracket. And you guys have to add this to your program also. These are called inline comments, whereby you basically say what is happening at that step. So inputting a value in the variable max, close bracket, outputting instructions, close bracket. So you basically say what is happening. Storing 0 into variable line, and that's how you do your inline comments. I also said that you need to add some comments at the very beginning. Who is the author? Who created it? What date you would have created it? 28th of January. Well, you're going to pick your day when you created your program. What is the purpose of the program? And you put in a purpose. And you close bracket there. Now notice, even though I went to different lines and type in information, once I open a curly bracket and closed it, it's going to be considered a comment. All of these are going to be considered a comment. And it does not affect your program. All it does is basically add additional information when you are reading the code. So that is how you do input. This is how you do output. So we can see how it works. We compile and we run. So notice we have our output here. Please enter how many times to run the loop. And if you notice, the cursor is blinking here. So it's basically requesting an input. So we type in the value and we simply press enter. And that's going to get stored in this value variable called max. So that's how you do output, and you store a value into a variable. You do an input. Now, this program, what this program is doing, it's a dynamic loop in that I can basically say how many times to run the loop for. So if you guys are interested in adding this into your program, this is how it basically works. That the while loop, that's the while keyword. We're saying basically the question, the criteria is while the variable line is less than the variable max, do the following. So once again, the while loop, the criteria to enter the loop is while the variable line is less than max. So once that is true, we are going to enter the loop. Now we initialize that variable line with a 0. So it's going to start off with a 0 here. Now this max here is what we are inputting here. So it's basically 0 to whatever number I input. And that's how many times the loop is going to run for. So this is how you create a dynamic loop. If you want the person to enter 5, compile, run, please enter how many times to run the loop. If I enter 5, it's going to run for 5 times. Run again. If I enter 2, it's going to run for 2 times. So because it's running until it is less than what I enter into max. And because I am updating the variable line, remember it's going to keep adding 1 to that 0 until it reaches that maximum value and ends the loop basically. So if you want to create your program with a dynamic loop, this is basically how you do that. But as I showed you guys, The for loop is basically the simplest loop that you can create. This is the example of the for loop here. So the for loop, you simply say for keyword, the for keyword, the variable that you're using to monitor the loop. You simply say what variable is, what value is going to start from to what value it's going to end. So if you say 10 down to 1, it's going to count down from 10 to 1. So basically the loop is going to run for 10 times. If you say 1 to 10, it simply means the loop is going to run for 10 times also. If you say 1 to 20, it's going to run 1 to 20 times automatically for you. You don't need to do anything else. It's going to run 1 to 20 times for you. So that's how you can carry out a for loop, this simple line here. And by putting this begin and end, whatever is inside of it is going to be looped continuously. So I have a 10 there, compile and run. So notice I have the output here 10 times. If I do 100, 1 to 100, run, it's going to keep going all the way until it reaches 100. So once again, if you notice, there is no update like the while loop. There is no update, line equal line plus 1, because the for loop automatically updates itself. It automatically changes from 1, 2, 3, all the way to 100. And there is no initializing. So like how we initialize line with 0, we did not need to initialize in the for loop. Basically, in the for loop statement, we're actually initializing it. Because this here, notice this is similar to the initializing. We're basically saying start it off with a 1, initialize it with a 1, and then automatically increment all the way to 100. So that's how you do the for loop there. So, like I said, we already covered all of this. That was just a recap. We looked at all of those loops. We looked at how to create a if statement. We looked at how to create the nested if statement. This was that example, the nested if statement, one if inside the other. All of these things you guys have to use in your program. And then a simple while loop. This one doesn't have that dynamic entry whereby you see how many times it run for. This was the example that I made dynamic. So this one here, it's running while line is less than 10. So instead of max earlier, a simpler version would just be to enter the value that you actually wanted to run for. 10 time, 20 time, whatever the case may be. And it's going to run for that amount of time. Similar to the while loop. Whatever is between begin and end is going to be carried out. So, like I said, we covered all of this. That was for the program aspect. If you guys have any question on any part of the program you weren't clear on, you can let me know so that we can clear it up before we go ahead. The if statement, the loop statement, input, output, calculation. So this here is an example of how you do calculation. You simply put your formula on the right hand side, your equation on the right hand side, whatever you're adding, whatever you're subtracting, whatever you're multiplying, and you say colon equal to, and it gets stored in the variable on the left hand side. So for example, if you wanted to do total is equal to 5 times 100 plus 50 divided by 5, Hopefully that works. And then we write line total. We should see the answer there. So we're gonna say first though that total equal. I'm gonna put that instruction so we see our answer. So I'm just showing you how to do a calculation. In your case, you would put your variable names to substitute the values and so on. So compile. I haven't declared total, so I need to declare it. Total equal real. Compile, run. So notice I have it here. Total equal 5.1, so. So that's how you do a calculation and you output. But notice I have a lot of decimal places. So how do we fix that? Well, where you're outputting the variable, like for instance in this line here, I'm outputting the variable here, you simply put a colon 0, colon 2. So the 0 here, can't quite remember what it does, so you keep it as 0. But the last 2 is how many decimal places you want to appear. So if you want 2 decimal place, compile, run. Notice I have 2 decimal places as my output. If I want 5 decimal places, compile, run. Notice I have 5 decimal places there. So that's how you format your real to give you your decimal output there. So I'm assuming there is no questions or nobody wants to ask a question on your program. So we're going to move ahead to the trace table now. So how do we create our trace table? So that's the final part for our program. So if we look at our program instructions, yeah, so the programming part of our SBA, part 5, problem solving and programming. The first thing you had to do was to create a pseudocode. So you were already shown how to do that. We're going to look now at how to create a trace table. I already showed you how to create a problem statement. And we just wrapped up how to create a program. Well, creating a program was wrapped up since last week. So how do we create a trace table now? The trace table is created by using your pseudocode. So you must complete your pseudocode. Your pseudocode must be correct in order for you to create your trace table. If your pseudocode is not correct and you go and make your trace table and then you have to fix your pseudocode, then that means you have to fix your trace table also. So for those of you that are here, before you go ahead with your trace table, please ensure your pseudocode is correct, that it would have confirmed that it is correct first, before you go ahead with start creating your trace table. So how do we create it now? Now, the trace table is very simple. Just that it takes a bit of time to create, but it's simple to create. I think I already sent this file in the group. So this is a sample trace table. This is just an idea. This is not exactly going to match what you have. This is just a sample as to how it can look like. So what you want to do is basically in the first column to number your steps. That's the first thing you need to do, number your steps. So you can simply type in step 1 and then use autofill and autofill the rest of the steps there, basically step 1 to whatever. So like I said, unless you would have completed your pseudocode, only then you will know how many steps are in your pseudocode. If you have 20, 25, 30 steps in your pseudocode, only then you will know. So that's why you got to complete it first. So the first column is going to be your step numbers. Now, your column headings. How do we get our column headings? Your column headings are in relation to the step number. You're basically looking at the intersection. So for instance, cell B2 is the intersection of step 1 and this B column here. So what you need to do is to look for the variable at that step. So if you look at the pseudocode on the left hand side, you can see that at step 1, the variable here is count. So I'm putting that as my heading. At step 2, now it all depends on how you would have written your pseudocode. Some persons have, like how I would have created it. Some persons did like how I created it. They combined these two as one step. So we're going to use the variable first name. That is the variable for step 2. But if you would have created yours like this, step 3, you basically separated these two into 2 different steps. Then basically your heading is going to be output. Your heading is going to be the keyword instead. So in this case, you're looking for the keyword. So step 2 would have been output instead of first name. And then step 3 would have been first name. And you continue like that for all of your steps. You look for a variable. If there is no variable, you look for a keyword that you can use. Like for instance, output, input, and so on. But usually when you have an input, like for example here, you already have a variable. So you won't have to worry about that. It's only the output would usually not have a variable. So you would use that keyword. Step 4 would have a variable health. Step 5 would have a variable union. And you continually go down the table and put it in the next column. Now, when you come across the step where you are running the tests, you're going to put that test. You can either put if, or you can put the entire test. If gross income is less than 65,000, notice in my example, I have that inside of my column heading. So like I said, whatever is, you're looking for a variable, the corresponding variable for that step, and you're putting it inside of the column heading. If you do not have a variable, you're looking for something specific from that step to put inside of the heading. Either some keyword or some action that is going to be carried out. So you have to do that for the entire table. You number the entire steps, and the column corresponds to the step, the intersection once again. So basically, at that intersection, what you're basically doing is saying what value or what is happening at that step. You're tracing what is happening at that step. That's why it's called a trace table. You're tracing what is happening at that step. Like for instance, at step 1, count is going to start off with a value of 1. So I have 1 here. Now this table here, you need to copy this table and basically continue this table, because we have to do it 10 times basically. We have to do the same thing 10 times. So when this program does repeat itself, this 1 is going to increase. It's going to increase to 2. So here now, instead of 1, we are going to have 2. And it's going to have 2 throughout this step here. This one variable, this variable count, is going to have 2 throughout this step here. So that's basically what you have to do. You have to create your table with your steps. Then you have to put the corresponding variable keyword in the corresponding column. Remember, that's the intersection, right? So here is the intersection for last name. Cell D4, that's the intersection for last name, and step 3. Notice that's let me put it back how it was. So this was supposed to be step 3. Good. So notice here I have step 3 for last name in my pseudocode, and in my table I have step 3, and the intersection is last name. So you're doing that to create your table. Now, once you have done that, as I said, you have to now trace your variables, trace your steps to basically see what is happening at each step. So you're basically going down in a stepped manner. You're going down and putting in the values in the intersection area. So as I said, at step 1, count was 0. Now, how did I get at step 2? James is the first name. How did I get that? How did I get Harry is the last name? Well, what you need to do, notice the sheet names at the bottom. I named this one here trace table. The next sheet I named it test data. This test data is data coming from your spreadsheet. All you simply need to do, open your spreadsheet, and you're going to see that you already have first name and last name and gross income for your customers. All you simply need to do is copy that information, copy 10 different customers, and paste it into this spreadsheet here. And that would have that there is how you create your test data. So you're basically using data from your spreadsheet as your test data. And you're basically using this here to test your trace table. So notice the very first name is James Harry. So James is the first name, last name is Harry, and notice the gross income is 270,000. So when I go to my trace table now, notice at this intersection here, I have James at step 2 for the first name. I have Harry here at step 3 for the last name. The next cell, I have 270,000 at step 4 for gross income. And you keep going like that. Now, when you're going to reach your calculations, like for example, when you're calculating health and union, you can either calculate it manually, like pull out your calculator on your phone or your physical calculator, calculate it and put in the answer, or you can make it easier on yourself and create a formula. You simply say equal, and you should already know the formula. The gross income multiplied by whatever the percentage is health. If it's 2% or 3%, and we get our answer there. Same thing for the union. You can either calculate it manually or simply create a formula. Gross income times 2%, and we get our answer there. So you can do that for your calculation, to trace your calculation. Now, when it comes time to trace this if condition, if gross income is less than 65,000, what do? At this step here, you have to indicate if it is true or false. So, is gross income less than 65,000? That is false. That's all you have to do. So you're simply answering the question. Is 270,000 less than 65,000? false, and you enter false. So we move on to the next step. Then, now remember this then here is only carried out if the answer is true. So in this case, the answer is false. But that means we have to ignore it. What do we do when we have to ignore a step? You simply put a dash inside of it, or you can leave it blank. You put a dash to indicate that that step was ignored, or you can leave it blank if you want. But put a dash. That would indicate that you actually looked at the step and you weren't considering it. You were ignoring it. So we move on to the next step. That's step number 8 here. Is gross income less than 100,000? So that's false here again, right? Because the 270,000 is not less than 100,000. So that's going to be false there. Now, because it is false, we have to ignore this true. So we put another dash for this pay tax here. And we keep going like that over and over. The step number 10, we have another pay tax. Now, because it is false, we have to carry this out. So that's simply, we have to do a calculation. So here, it might be equal to 270,000 times 10%. And we get our answer there. And you keep going like that until you reach the end of all of the steps. That is how you trace the pseudocode. That's how you create your trace table. You go from step 1 all the way to your last step like that. And when you're finished with one table, you have to do that again. You have to do the same thing 10 times. And that's how you complete your trace table. I can show you an example of someone that of what the final is going to look like. So this is the example of a previous year trace table. So the color coding can help you to differentiate the table. So that's why I told him to color code it, so that we can tell that this is one loop. Basically, each repetition of the table is a loop. And remember, we have to run the loop 10 times. So this here is one loop, second loop, third loop, and continue all the way to 10. So we can have a look at theirs. So notice it's basically the same thing as I showed you. We have steps here, we have the number of the steps, and then we have the corresponding heading at the top here. And then the value in the intersection of that step number and the variable or the keyword that you have in that column. And you keep going like that until you reach the end of the table here, basically. Do we have any questions on the trace table? Were you guys able to follow that? Are you clear on it? Trace table. So this here is an example of a much more simple version of it. Our one is going to be more complicated because we're working with more steps. We're working with more lines, but it's basically the same principle. This is step 1, and they put the value here 0 for that variable I. This is step 2, and this variable j has a 10 inside of it. At step 4, I'm not sure why they skipped step, for some reason they skipped step 3. At step 4, they have a test here. If I is less than j, that's true, because 0 is less than 10, so they put true. And then I'm assuming this is a loop. So they continue here. At step 5, I turn to 1. At step 6, j turn to 9. And the same question again. Is I less than j? And we have true here. So once again, before you create this trace table, you must ensure your pseudocode is correct. So don't go and start the trace table if you have not confirmed with me that your pseudocode steps are correct, because the steps number have to be correct first. Now, if I say the pseudocode is correct, everything is perfect with the pseudocode, then you go ahead and create your trace table. You create one table first, and then I can check that and tell you if you would have created the layout correctly for your table. And then you can copy that format of that table. Once I say that's correct, you copy the format of that table 9 other times so that you get your 10, and then you start tracing all of your tables. Remember, you get your test data from your spreadsheet. So that's basically it for a trace table. Any questions from anyone? It's simple, but just that takes some thinking. It takes time. It may look like a lot of work. Technically, it is a lot of work. All right, program, we covered everything there. We covered everything for problem statements. Design and execute a trace table to test the algorithm. Test the algorithm with applicants to the housing community. Data types to have a spreadsheet. Table have a maximum of 10 iterations, and variables must be added. So these two criteria here, tables should have a maximum of 10 iterations. So that's why we're telling you to create the same table 10 times. That's going to fulfill this criteria here. That's number 4. And number 5, variables must be identified. They're identified by putting them in the headings here. So that would fulfill that criteria there. All right, so I'm not going to go ahead with anything because that's basically it. That's basically everything you need to cover your SBA. So I'm going to give you guys the rest of the time to complete your SBA, whichever other SBA you want to work on also. You can do that. But if you have any questions on any part of the IT SBA, you can ask me now. Otherwise, we're basically going to wrap up here for tonight. Anything on the pseudocode, anything on the program, trace table, problem statement. If you know you're good in all of them, you don't have any questions in all of them, you're free to take your leave. Otherwise, you can ask your question.